All right, so let's take another step back. All right, so this is like I said earlier, we only have sunspot records that go back to the early 1600s. So this is another means to measure the temperature, and this is the Greenland Ice Sheet Project. It's a GISP-2, GISP-2. So we're just going to focus on this box right here. So the next box is this chart here. All right, so now we're just zoomed in on these periods here, right? So this is the Greenland ice core data. These peaks here, right? We have the Minoan warm, the Roman warm, the medieval warm, and the time that we're living in now is called the modern warm. Okay, so they note the names of these warm periods based on it's noted that these warm periods also note the peak of that civilization, right? The peak of the Minoans, the peak of the Romans, the peak of the medievals, right? And peak of modern
Sure.
warm here.
Sure.
Yeah, peak of us, to say more simply. So, and that time is Little Ice Age. We're right here. So, just like Dr. Jack Gady did, you can look at history. We have history that goes back to the Bronze Age. Right? We can read history books and we can see what was happening. Right? We see nothing but strife and suffering all during these times of cold. Right? We see prosperity and growth all during times of warmth. Again, because humans thrive in the warmth. Right? We absolutely thrive in the warmth. Again, it's about perspective. We humans are fragile creatures. We think we're masters of our universe because we have smartphones and we can drive cars and right, we can go to the bathroom and turn on a faucet and there's water right there in our house. Right, we think we're masters of the universe. But take away these luxuries and we are no more than cavemen with cell phones.
Yep.
We are not as civilized as we think we are, not by a long shot. So these people who lived during these times, remember, they knew how to live off the land, right? All right. So far, we established three things. That sunspots occur in cycles. Sunspot activity is an indicator of Earth's temperature, and these cycles occur in predictable patterns, right? So far, that's what we established.
Yep.
So let's talk about TSI, right? Total solar irradiance. So energy from the sun is measured in watts per meter squared, WM2. So this chart here is TSI going back to the early 1600s. Now, what does it look like to you? It looks almost identical to the sunspot observation chart, right? Almost identical. So, well, we can look at TSI down here. Well, let's look at the Maunder minimum. How much TSI did Earth receive during that time? And how much are we receiving now in this warm climate? So a reduction of TSI, roughly 3 to 4 watts per meter squared, is the difference between Jamestown, right? Some of the coldest times in recorded American history, and then this modern warm we're living in now, right? A small change, right, between 3 and 4 watts per meter squared. Now, it's one thing to note on here is TSI is kind of like Fahrenheit and Celsius. There's two different numbers. If you're looking up TSI and you find a different number that's way different than this, you're looking at the either Fahrenheit or Celsius one, or just vice versa.
Well, I know they changed the way that TSI was measured, and I think it's like a 4 value difference now. So in other words, if we use the technology to measure TSI back in the Maunder minimum, we would be looking at TSI levels at 1359.5.
Okay.
So I'm pretty sure that's what it was, that we had two different ways of measuring it, and with updated new technology, it's adjusted a little bit and it's lower than what these numbers are here. So if we had to translate them, that, from what I was taught as well, this is translating to under 1360 is
Right.
where you usually see that threshold for grand minimums. So,
Okay.
and that matches up here with that as well.
And we're knocking on the door.
Yeah. Oh, yeah.
Right. All right. So this chart, this chart didn't make too much sense to me until I really sat down and really spent some time deciphering it. So let's first look at this bottom section here, right, with the red box on it. Right, ignore the top section. All right, let's just look down here. So this is a Russian chart. I'm not going to even attempt to pronounce that name. All right, so here we are still counting sunspot numbers, right? These are still the Schwab cycles, right? 11-year cycles. So here we are right here, all right? Solar cycle 24. Now, one thing that all of these charts don't give you, they don't give you depth, right? You're viewing these on a linear plane.
Right.
You don't realize how low this is because there's nothing to compare it to because you're just counting sunspots, right? You can't have less than 0 sunspots. 0 is 0. So let's factor in TSI, and that's what the upper chart does. It adds TSI and the sunspot counting. So we're looking at here, look on the left side of the screen here, all right? That's now,
Right.
right? So here we are right there. So during the modern minimum, there we were, right? So well, where are we going? By 2040, that's where we're going.
Wow.
So if you study the work of Dr. Valentina Zarkova, right, heading down there. So this is the difference between landing at Jamestown, right, catastrophic casualties of the settlers, right? This minor change in solar activity causes a drastic effect on our planet. Well, what happens here, right? Or what happens down here? Again, we're fragile creatures.
Well, and in that graph right there is also very important for people. Not only does it show us how much TSI we lose over
Right.
the next several decades, which, I'd like to say that I'm going to be here in 2040. So, according to this chart here, looking at the solar activity, now folks have predicted that solar cycle 25 might be slightly, and I'm talking slightly higher than what we saw in solar cycle 24, which is not much to speak for. So
Right.
even if it's slightly off, you can clearly see the trend. And what's alarming is we are definitely at the very beginning of this long descent.
Yep, absolutely, absolutely. This is a long road. All right, so let's look at some proxy data. All right, so we can look at the history of disease and plagues. Right, some of you listeners know where it came from ADAPT 2030. So history of diseases and plagues. Right, you can correlate. You can find that there is a direct correlation between a cool planet and an increase of diseases and plagues. Well, why is that? Because when a planet is cold, it's more difficult to grow or store food, and people can't eat, and their immune systems go weak, and they're more susceptible to diseases. It's really that simple. But just we don't have the right perspective or the lens to really see it. All right. We can also look at Chinese dynasties. Right. These are Chinese dynasties collapse. Right. Always during times of cold. Right. Every single time these dynasties collapse when the sun cools off. Why is that? Same thing, because no civilization has ever outlived its food supply. Again, nothing is more important than your ability to put food in your mouth 3 times a day. That's it. All right, so let's take a big step back now. All right, real big step back. So we're living in a time right now called interglacial. Right. So here we are here, right here to present. So the normal temperature of this planet is cold. Right. With intermittent warm periods, intermittent cycles, right? Cycles of civilizations, ancient humans, right? Again, these megalith structures are likely not always aliens, right?
Right.
They had different technology. All right. So I threw a 10-minute break in here because I give this presentation in a stand-up kind of lecture format. So this will be the fastest 10-minute break. All right, so we're back from the break. Section 2 talks about the current status. Again, I present this lecture in a way that I assume that nobody knows anything about anything. Most people have no idea the sun even operates on a cycle, right? So I also have to, accept that they likely don't know about the IPCC or global warming or all this other nonsense. So I have to really walk them through it.